Chalo. In the last class, we started with the group 17. Okay, we started with the group 17 in our last class ended at, let me check just a minute. Our last class ended at the oxidation states. We were doing the oxidation states. Yeah, we were doing the oxidation states. Where is the oxidation state? Here. Okay, so let us continue from the oxidation state. Now in the PPT, I have added everything. Okay, so some of the page I might just go ahead because I have added everything, every small detail I have added in the PPT. So even if you read the PPT, it is fine. Okay, nothing will come outside of this probably. Okay, chalo. Let us continue from the oxidation state. Group 17. Yes, what are the, or tell me, what is the valence electron in the group 17? What are the valence electron in the group 17? Sarjana, Prashansky, and come on, tell me. Group 17 valence electrons. That is 7. Correct? It is 7. So let us look at the oxidation state. Let us look at the oxidation state. Look over here, everyone. So that is why our valence, the valence electrons are 7. If I go into detail, for example, fluorine. Fluorine, what is the atomic number, everyone? Yeah, what is the atomic number, Sajna, for fluorine? Prashansky, Gopinath, what is the atomic number for fluorine? Yes, it is nothing but 9. It is nothing but 9. Okay, so for fluorine, it is 9. So if I write down the electronic configuration, it is 1s2, 2s2, 2p5. Correct? So these are my valence electrons. So ns2, np5. Correct? ns2, np5 is my valence electron configuration. So due to that, okay, this is the ground state. Fluorine is anomalous because the fluorine size is very small. Okay, that's why it might show different behavior. It will show different behavior, but I am talking all the elements except fluorine. Okay, that is chlorine, bromine, astatine, okay, and iodine. So over here, the possible oxidation state, see, you have one value that it can be gained. So therefore, if it is in the ground state, the oxidation state can be -1, +1. Okay, we will do all the elements with those oxidation state also, do not worry. Then first excited state, what has happened? One of the electron jumped over here. One of the electron jumped over here. So 3 valence electrons, so +3 oxidation state, correct? Then again in the second, what has happened? One more electron, let us say, jumped over here. Correct? So how many valence electrons now we have? 1, 2, 3, 4, 5. Correct? Half filled, not only valence, the half filled electrons is the correct one. Okay? Because to form a covalent bond, you require one electron of your atom, you require other electron of other atom. Correct? So 5 half filled electrons, so hence it is +5. Then in the third excited state, what happens? This again jumps over here. Okay? So let me erase this. This should not come. Okay? This has jumped. So 1, 2, 3, 4, 5, 6, 7. So +7. Okay. So what are the possible oxidation state? Only for fluorine, it is -1. That's it. Okay. Fluorine can take only one electron. Nothing else it can donate. It cannot do anything. Only thing it can do is to gain one electron. That's why fluorine -1. That's it. Remaining everything what we have done, -1, +1, +3, +5, +7. Okay. -1, +1, +3, +5, +7. Okay. Similarly, bromine and iodine. So remember, your fluorine is an exception due to the small size. Yeah. So it is -1. Okay. So note it down. Fluorine is the only halogen with the only one oxidation state, that is -1. Okay. Now look over here. Reactivity. This is important. This is important. See, now your halogens, they are very reactive. Okay. Their halogens are very reactive. Now, what is this dissociation enthalpy? Yeah? What do we mean by dissociation enthalpy? Dissociation enthalpy means what? Dissociation enthalpy means we have any molecule, like for example, we have fluorine, we have chlorine. Okay, we are talking about the dissociation enthalpy of this molecule, fluorine, chlorine, bromine, iodine. Okay, we are comparing the dissociation enthalpy. Now, enthalpy means what? Energy. Dissociation means what? Breaking of the bond. For example, F2 is becoming 2F. Cl2 is becoming 2Cl minus. Okay, are you getting it? So energy required for the dissociation. Again, it shows little bit exception. It shows little bit exception. Okay. Now, reactivity down the group decreases. Okay. Reactivity, remember, fluorine is the most reactive. Write it down. The most reactive is fluorine. Okay. Most reactive is fluorine. Okay. Then down the group, remember the reactivity decreases. But look at the bond dissociation enthalpy. There is slight exception. Okay, there is a slight exception. Look at the bond dissociation enthalpy. Chlorine is the highest. Okay. Then we have bromine. Then we have fluorine. Note it down. It is an exception. Can be asked. This is a bond dissociation enthalpy. Okay, bond dissociation enthalpy. Okay, bond dissociation enthalpy. Okay, write it down and done in the chat box. Okay, chlorine, bromine, fluorine, and iodine. Generally, it should have been fluorine, chlorine, bromine, iodine, but fluorine comes last. Okay, the most reactive is fluorine. The most reactive is fluorine. Okay, then reactivity and oxidizing power. Okay, everyone. Okay, everyone. Let's. I have some important work to do. Let us take a just 10 minutes break. Okay, we will continue after 10 minutes. There's one important call I have to take. Okay. Till then, if you want, what I can give you. Okay, what I can give you. Okay. So let's do one thing. Till then, you have this compounds. Okay. Two things. We have done VSEPR. Okay. Find out the VSEPR. Find out the VS according to VSEPR. What will be the hybridization? Okay. And what will be the shape of the compound? Okay. Hybridization and shape of the compound of, let me give you 1, 2, 3, 4, 5. Okay, I'll be back in a, like, I might take 10 minutes. Okay, is it clear, everyone? Yes, everyone, are we back? Come on, back in the chat box. Are we back? Okay. Break is done, no, for today. Okay. So where were we? I told you before going to the break to find out the VSCPR. We'll come to this topic and then we'll discuss. Okay. Let us continue now from where we left. Okay. Okay. So we are done with the reactivity and bond dissociation enthalpy. Okay. Now your halogens, they have a very good oxidizing power. That means what? They are strong oxidizing agent. Can anyone tell me what do we mean by oxidizing agent? We have reactions of this as we go ahead, but what do we mean by oxidizing agents? Yeah, what is the meaning of oxidizing agents? Yeah, correct, Sarjana. Yes, oxidizing agent means what? Who are oxidizing agents? Yeah, correct. It undergoes reduction but oxidizes the others. Perfect. As you go down the group, the oxidizing power decreases. So remember, oxidizing power decreases down the group. Okay, oxidizing power, it decreases down the group. Okay, as you go down the group, the oxidizing power decreases. Oxidizing power decreases as you go down the group. Okay, now look at this reactions. Okay, look at this reaction. Okay, so hence we can say that F2 is the strongest oxidizing agent while I2 is the weakest oxidizing agent. Correct? That is what we discuss now. F2 will be the strongest, then we have chlorine, then we have the bromine, then we have the iodine. Okay, and vice versa. This is the power for oxidizing agent. Yeah, this is the, write it down, this is the oxidizing agent power. Correct? And reducing agent, it will be opposite. Reducing agent, it will be opposite. Correct? Good evening, Ragul. You joined late today. So this is our oxidizing agent. Reducing agent will be opposite. Okay. So let us look at the reaction. Now this Born-Haber cycle, have you done? This is there in your equilibrium. This is there in your thermodynamics. Do you remember Born-Haber cycle of 11th standard? Anyone? Born-Haber cycle? No? Born-Haber cycle? Yeah? Anyone remember from your 11th standard? Born-Haber cycle. You have the Born-Haber cycle of NaCl. Do you remember? No? Achha. Anyways, so Born-Haber cycle tells you about the total energy. Okay, it is there in thermodynamics, I guess. It tells you about the total energy that is required for your reactant to convert into product. Okay, what all the process it has undergone. Okay, over here there is no use of Born-Haber cycle, but Born-Haber cycle tells you about the total energy. Okay, it tells you about the total energy. We will look at the reaction first. Okay, the fluorine, chlorine, bromine, iodine, the oxidizing power reaction. Let us look at the reaction. Look at this. Let us look at the chemical properties. Okay, now one more thing, as I told you, fluorine shows anomalous behavior. Now over here, anomalous behavior means what? Yes, it follows all the same trend, only the numbers. Okay, the numbers, due to the size of fluorine, it is very high, or it will be very low as compared to the other numbers. For example, fluorine is the most electronegative, correct? So the fluorine electronegativity is 4. Then you have chlorine, bromine, iodine. Okay, so these are in the range of 3. Okay, so these are the range, in the similar range, but fluorine will be very high apart from this. That's why we are calling it as anomalous behavior. Why it is like that? Because due to the smaller size of the fluorine, it behaves like that. For example, ionization enthalpy. Look at this table. Ionization enthalpy. Look at this table. Okay, so over here, look at all the properties. Okay, let us say ionization enthalpy. Okay, now look at the ionization enthalpy of chlorine, 1256. Look at the bromine 1142. Look at the iodine 1008. So they are all in the range of 1100, 1200. Hardly the difference of 100. Okay. But look at the fluorine 1680. That is almost 1700. So what is the difference between them? Almost 500 difference. Are you getting it, everyone? Almost 400 to 500 difference. So that is what meaning anomalous behavior over there. That yes, ionization enthalpy, it follows the trend. Fluorine, chlorine, bromine, iodine. Yeah, there is no anomaly in that. But the anomalous behavior is that the fluorine shows very, very high value over here. Same with the electronegativity. Look over here. 4. All are in the range of 3.2, 3, 2.7. That means hardly 0.2 difference. But if you look at fluorine, 0.8 difference. Are you getting it, everyone? Yeah, that is the meaning of anomalous behavior over here. That look at the difference in the numbers. Okay, it follows the trend. Everything goes properly. Only thing is the values are very, very high or very, very low due to the size of the element. Okay, even the hydration enthalpy, look at this, 381, 347, 305. Okay, it follows the same trend again, but look at the value, differ by 200 to 300. Yeah, why is it? Because of the size of the fluorine. Is it clear, everyone? Come on, give me yes or no. Is it clear? Yeah, is it clear? Okay. Now look at this. Let us look at the chemical properties. Now, what are these? HF, HBr, HI. What are this? Yeah. What are this? Base, salts. What are these? Yeah. HX, Ragul. Mineral acids. These are acids. How do we define acid? And Ragul, Sarjana, Prashanti. How do we define an acid? Prashanti, what is an acid? Yes, Sarjana, what is an acid? How do we say acid? Correct, Sarjana, very good. Yes, Prashanti, correct. And what is an acid? Prashanti, yeah. Acid is something, Ragul, what is an acid? Yes, acid is something that gives you H plus. Correct? Acid is something that gives you H plus. Now, what is strong acid? We have already discussed this. What is strong acid? Yes. What do we mean by strong acid? Yeah. What is the meaning of strong acid? Yes, everyone. What do you mean by strong acid? Yeah. Someone tell me, what do we mean by strong acid? Correct, Sarjana, correct. And Ragul, what do we mean by strong acid? Bhuvaneshri? Yeah. Prashanti, what do we mean by strong acid? When I say I have a strong acid, what is the main difference? That you say this is my strong acid, this is my weak acid. Correct, Prashanti? Better is which gives away H plus easily, isn't it? Acid is something that gives you H plus. So the one which gives you H plus more easily is a strong acid. Simple as that. Simple as that. So, Sajna, if you remember, if I compare HF, HBr, HI, which is the weakest acid out of them? Yeah, which is the weakest acid? The good question, C. Yes, which is the weakest acid? And Sajna, what do you think? Use your logic, take your time, think about it. Bhuvaneshri, what will be the weakest acid? Yes, Sajna, what will be the weakest acid? Take your time and think about it. Think about all the possibilities. What will be the weakest acid? Weakest acid means what? The one which will not give H plus easily. That will be your weakest acid. Okay. Yes, Ragul, what will be the weakest acid over here? Bhuvaneshri, HBr, okay. Which will be the weakest acid over here? Sajna? Correct? Yes, correct. And correct, Sajna. Bhuvaneshri. No, Rakul, it is not HBr. It is HF. HF. You know, HCl, HI, HBr are considered as a strong acid. HF, although it is a mineral H plus acid, we consider it as a weak acid. HF is a weak acid. It is not even strong acid. Forget about the better strong acid. It is not even a strong acid. It's a weak acid. Okay, just like your acetic acid, we consider HF as a weak acid because look at the sizes. Yes, Ragul, Bhuvaneshri, Sajna, look at the sizes. Yeah, HF, they are comparable. HBr, okay, slightly large. HI, okay, it is like ant and elephant. Can your ant hold down the elephant? Forget about the electronegativity. Can your ant hold down the elephant? Can you hold elephant? No, na. So obviously, so imagine H is of your size, your iodine is of elephant size. Yeah, we cannot hold them. Yeah, so yes, it breaks away easily. That means H plus gives easily. So HF is a weak acid. So whenever you react any halogen with hydrogen, simple what it will form? It will form acid. Yeah, don't write down this reaction. H2 plus F2 gives you HF. H2 plus Cl gives you HCl, not HF. It should be HCl. H2 plus Cl2 gives you HCl. Okay. Similarly, H2 plus I2 will give you HI. H2 plus Br2 gives you HBr. Simple as that. Simple as that. Simple as that. Then next, as we discuss, acidic strength increases as we go down the group. So HF is the weakest. Then we have HCl. Then we have HBr. Then we have HI. Yes, this is our acidic strength. Write it down. This is our acidic strength. This is our acidic strength. Okay, this is our acidic strength. Okay, this is our acidic strength. This is the acidic strength. Okay, so thermal stability also decreases. Isn't it logical that H will go away easily? So even if I give away little bit of heat, it will break. It will break. So stability is not there. So thermal stability decreases again. Same for the acidic strength. Same for the thermal stability. Same for the thermal stability. Okay, same for the thermal stability. Is it clear, everyone? Same with the reducing character. Okay, so reducing character increases. That means what? It gives away H plus more easily. It can reduce the other substance better. Simple as that. Okay. Is it clear till over here? Ragul, Sarjana, and Prashanti, Bhuvaneshri, is it clear? Someone give me yes or no. Let us go ahead. Okay, so affinity for H decreases from fluorine to iodine. Now, look over here. Do not get this statement wrong. Okay, affinity of H decreases from fluorine to iodine. Now, fluorine is highly electronegative, correct? So, if I have H plus in any solution and I have fluorine in any solution, they will always try to come together because H plus has more affinity towards fluorine. Okay, that's why affinity, yes, for H plus decreases from fluorine to iodine. And acidic strength, we have just written it down that acidic strength, yes, HI will be your strongest, then HBr, then HCl. HF is a weak acid. Okay, HF is a weak acid. Opposite will be your bond dissociation, and that acid, Prashanti, the H and F bond will not break faster, so it will require more amount of energy. That's why bond dissociation enthalpy for HF will be highest. Come on, write it down. Bond dissociation enthalpy for HF will be highest. Then you have HCl, then you have HBr, then you have HI. Come on, write it down, everyone. These trends are important. See, whenever you will revise, no, make a short book. Okay, just like you have a formula book for physical chemistry, for inorganic chemistry, you make these trends, all those formulas, the color, magnetic properties. Okay, from every chapter you have to do that. Are you getting it? Yeah. So you have to do that from every chapter. So do not leave inorganic chemistry because it is theory. Okay, study inorganic chemistry in a pattern. Then only it is possible to remember this. Otherwise, very difficult. Okay. I am not saying to mug up this thing. but you should go through this regularly. Clear, everyone? Come on, write this down and done in the chat box. And is done. Sarjana is also done. Prashanti, come on, write it down and done in the chat box. Okay, fine. Okay, so this is the number again. HF higher, then HCl, then HBr, then HF. Okay, then HF. Okay, then even this H2O does not show any acidic character. Okay, although no logic with the group 17 elements, but you should remember that H2O H does not show any acidic character. H2O is neutral. Apart from this, this show certain type of acidic character. Okay, all the H2 will show the acidic character except H2O. H2O is neutral. Okay, now reactivity with oxygen, important, mark it, important. Reactivity with oxygen. Okay, we have the reactions with oxygen. This is where I was coming to. Okay, reactivity with oxygen. Okay, look over here. Now over here we are learning about halogens. Do not forget. For example, if I say OF2, what is the oxidation state of fluorine over here, everyone? Calculate OF2. OF2. What is the oxidation state? What is the oxidation state of fluorine? Come on, calculate, correct, and Prashanti, Sajna, what is the oxidation state of fluorine in OF2? Okay, Anne says -1, Sajna says +1. Prashanti, what is the answer? Oh, it will be +1. How did you get +1? We are talking about fluorine. Look over here. Fluorine, I'll consider it as a X. So it is 2X. Oxygen is -2. So -2 plus 2X is equal to 0. So 2X. It is plus, isn't it? 2X -2 goes that side, becomes +2. X is equal to +1. Yes, Bhuvaneshri. Bhuvaneshri, how did you get 2? And calculate for O2F2. If I have O2F2, yes, if I have O2F2, calculate for F if I have O2F2. Yes, it will be what? -4 plus 2X is equal to 0. So 2X is equal to +4. X is equal to +2. X is equal to +2. Okay. Now over here, for fluorine, it should be +1. For fluorine, it should be +1. Okay. For fluorine, it should be +1. Okay. Now look over here. Then we have all the structure. Chlorine. Find out for Cl2O. Let us check if it is correct or no. Cl2O. Cl2O. Calculate. Cl2O. Cl2O. Calculate for Cl. Calculate for Cl. Calculate for Cl. Correct. It is 2X -2 is equal to 0. X is equal to, correct. X is equal to +1. Okay. Then we have ClO2. Calculate for ClO2. Is it correct? ClO2. Calculate ClO2. ClO2. Come on, calculate. If it is correct, correct Sadhana, correct and correct Bhuvaneshri. Okay. So over here for ClO2, if I find out the, I told you to find out the hybridization. Yes, what will be the hybridization? Did anyone find it out? ClO2. Yeah, anyone? Prashanti, Sajna, we have done this, and yeah. Okay, very good Prashanti, very good, and Sajna. Did you find it out? For ClO2, what will be the structure? What will be the structure? Yes, sp3 hybridized. What will be the geometry, everyone? What will be the geometry? Geometry, not the shape. I am asking about geometry. sp3 hybridized. What is the geometry? And Prashanti, Ragul, Sajna, what is the geometry? Bhuvnashri, correct? It is tetrahedral. How did we find out, Bhuvnashri? If I have chlorine, that means, Ragul, I have 7 valence electron, isn't it? I have 7 valence electron, isn't it? I have, oh, it is ClO2 or Cl2? Just a minute. Okay. Okay, ClO2, I have 7 valence electron, 2, 3, 4, 5, 6, 7. Okay, 1, 1. But it is not making, hmm, it is sp3, yes, it is sp3. Okay, but we are having one less electron, one more electron should have been there, no? Yeah, but yes, so this is not following our VSEPR. Should have been anion, but yeah, this is not following our VSEPR thing. But yes, ClO2 is sp3 hybridized. Okay, it is sp3 hybridized because it is tetrahedral. I have Cl, yes, I have oxygen, oxygen. There is a lone pair over here, and yes, I got it, Sajna. Okay, and a lone pair over here. So geometry is sp3, but the structure is bent. The shape is bent. If I remove the lone pair, the shape is bent. Clear? Okay. Then write this down. O2F2 is the only one. Okay, O2F2 is such a good oxidizing agent that it even oxidizes the plutonium. Okay, so we use this in some of the radioactive reactions also. O2F2. Come on, write it down. Mention it over there. Mention it over there. O2F2 oxidizes even the plutonium. Okay, O2F2 oxidizes the plutonium to plutonium hexafluoride. Plutonium hexafluoride. Okay, and with respect to this also, you write it down with respect to oxides. Okay, the oxides, we are going to come in, we are going to talk in detail about this, about oxides. But remember, okay, with oxides, your iodine, okay, iodine is the most stable oxide. Okay, we are going to come after this, but for now, write it down the trend. First, you have iodine, chlorine, and bromine. Okay, with fluorine, you have only one oxide, single OF2 and O2F2. Okay, only two oxides are there. So you have oxides with iodine, chlorine, and bromine with the order of stability. Come on, write it down. Stability of oxides. Stability of oxide. Stability of oxide. This you have to mention it in your book. Okay. Make a short book just for writing down the tricks. Yeah. In that you have to mention all these trends. Then only it is easy to do it. Otherwise, it will be very difficult. It will be very difficult. Okay. Now we have the reactivity with metal. So oxides of bromine are least stable. Okay, we are going to come at this. Okay, all the structures of oxides we have. We are going to look at this. Okay, the bleaching agent and all those one by one we have. Okay, then reactivity with metal. Now reactivity with metal. So with metal we have numerous halide compounds, isn't it? With metal we have numerous halide compounds. So write down this ionic character. Okay, ionic character. Ionic character, that means positive and negative, that you can say as a polarity also. Okay, ionic character, due to the high electronegativity, MF is the highest. Then you have, it is according to the electronegativity, then chlorine, then bromine, then iodine. Okay, then iodine. Write down the ionic character. According to electronegativity, the ionic character is there. Okay, and M is a monovalent metal. That means only one bond is forming between them. Okay, monovalent. That means they are in the +1 oxidation state. They are in the +1 oxidation state. Okay, they are in the +1 oxidation state. Okay, that is our ionic character. That is our ionic character. See this interhalogen compounds. See, interhalogen compounds. What do we mean by interhalogen compound? That means a halogen reacts with itself. Okay, halogen reacts with itself. That is an interhalogen compound. For example, IF7. Okay, over here I is also halogen, F is also halogen. Okay, so if I react iodine with excess of fluorine, I get IF7. But the condition is the multiple atom you have multiple atom of F. So that should be smaller size halogen. You will never find a compound like Fi7. Not possible. Okay, isn't it logical? Like one big element can hold 7 small elements, isn't it? One small element cannot hold 7 big elements, isn't it? Yeah. So same logic over here. Interhalogen compounds are very common. Yes. Only thing is the multiple, the poly atom you have, the poly halogen you have is the smaller size halogen, and the one halogen you have is a larger size halogen. Come on, write it down. Write down this. Formation of interhalogen. We also have this. Just a minute. We have this interhalogen over here. Look over here. We have this interhalogen compounds in details. In the next PPT, I have it in detail. The interhalogen compounds. See, look over here. This interhalogen compounds we are going to do in detail. So for now, just mention it. Yes, interhalogen compounds. We form interhalogen compounds. Okay, that is only the smaller size halogen is larger in number. Okay, or poly in number. You can write it like that. Okay, smaller size halogen is poly in number, or write down the type or example so that you will remember. Okay, you will remember. And you know, today I had brought something in the class. I had something in my class. Can anyone guess what is this? Can anyone guess what is this? Yeah? Can anyone guess what is this? I have brought gun to the class so that if you do not answer me properly, yeah, if you leave the session and if you do not answer me properly, yeah, I'll directly, yeah. You know what is this? Can anyone guess? Obviously, it looks like a gun, but it is not a gun. It is not a gun. Okay, I'll do with a gun? Okay, like I do not have to do. I have to kill anyone in the class? We do not have technology yet that I'll fire it from the camera and it will hit you. Yes, correct, Ragul. Correct, Bhuvneshri. Yes, Prashanti. And guess what is this? This is a pen. Okay, this is a pen. Yeah, I loved it. Yeah, that's why I brought it to show you all. Yeah, isn't it nice? Yeah. So this opens up like this. Today I kept it on my desk. Okay, so our head came on the desk. He was like, "What is this? What have you brought to the office?" So I showed him. So look at this is a gun I have brought to show it to my students. Yeah. Anyways, so I'm signing all the important documents in the office. Imagine a teacher signing his document. Someone from the management calls me. Okay, some senior management level people calling me, CEO and all those people, and I'm going with the gun over there just to sign. If I was not a good teacher, no, they would have thrown me out till now. Okay, anyways, done. Done till over here, everyone. Okay. Let us go ahead. Now let us talk about chlorine. Yeah, chloride. Where do we get the most abundant chloride? Where do we have it? In the form of free, but we still buy it. Yeah, chloride. Where do we get chloride from? Correct, Sarsna. And where is it present? From where do we get it? From where do we get it? Prashanti, the chloride. Correct. And where do we get chloride? The most common form of chloride. Where do we get it? NaCl. But where do we get NaCl? Yeah, where do we get NaCl? Yes, Prashanti. Where do we get NaCl? It is on the McDonald's fries. Yeah, isn't it? Hmm. Okay, so we get it in the form of NaCl. Correct? We get it in the form of NaCl. Yeah, we get it in the form of NaCl. Okay, which state of matter we get chlorine in? If I have Cl2, chlorine is which state of matter? Can anyone tell me? Chlorine, which state of matter at room temperature? Chlorine is in which state of matter at room temperature? Yes, Prashanti, have you seen it? Sarsna, chlorine, which state of matter? So fluorine and chlorine are gas. Correct, Bhuvaneshri. Fluorine and chlorine are gas. Okay, fluorine and chlorine are gas. Bromine is liquid. Okay, we have bromine liquid, and I2 is a solid. I2 is a solid which can undergo sublimation. Okay, so chlorine, important. Let us do this. How do we prepare chlorine? Okay, how do we prepare chlorine? Simple as that. If you see everywhere, wherever there is a chlorine preparation, this first four reaction, look at this. HCl, HCl, HCl. We are heating NaCl. That's why we have not done. We have used HCl because again it will give us NaCl back. Instead of that, we have used H2SO4. Okay, so we get Cl from NaCl. Okay, so over here by heating with concentrated HCl. So if I hit any metal, like for example manganese oxide. Okay, if I hit manganese oxide with acid, what I'm going to get? As I told you, see, some gas is going to come out. Yeah, so if I have HCl, obviously Cl2 gas is common. Obviously I have oxygen and hydrogen, so water will be given out, and what is left? Your manganese chloride. Okay, so this is the first preparation of chlorine. We get the chlorine gas from this. We get the chlorine gas from this. Okay, chlorine gas from this. Similarly, look at the third one. Okay, let's come to the third one first. Look over here. I have KMNO4. Again, KMNO4 heated with HCl. What I'll get? Again, release of a chlorine gas. Similarly, K2Cr2O7. Yeah, if I heat it again with HCl, what will be released? Cl2, that is your chlorine gas. And if I have alkali metal, yeah, alkali metal and halogen, they always come together. Yeah, alkali metal and halogen, they will always come together if you heat it them together. Okay, so this is how you have to remember the reaction. Balancing for the NEET, not that important, but you should remember what are your products. Okay, and that you will remember only with the help of practice. Otherwise, it is not possible. Okay. Now look at the second reaction. We have NaCl. Instead of HCl, I have used H2SO4. Why I have not used HCl? Because as I told you again, Cl will combine with Na and again it will give you NaCl. Okay. So what happens again if I have H2SO4 and NaCl? If I heat it strongly, again chlorine gases released. Again chlorine gases released. Is it clear till over here? Yes. The important reactions, I'll tell you to write it down. Okay, I'll tell you to write it down. Okay, now this decons process, we have to write it down. Okay, decons process and HCl on bleaching powder. Now mark it on the top, your bleaching powder. Okay, is your CaOCl2. CaOCl2 is nothing but your bleaching powder. Okay, CaOCl2 is nothing but your bleaching powder. Okay, CaOCl2 again if I heat Ca together, calcium is there, chlorine is there, obviously calcium chloride will come together, H2O and chlorine gas is released. Yeah, H2O and chlorine gas is released. Okay, write it down by action of HCl on bleaching powder. By action of HCl on the bleaching powder. Okay, by action of HCl on bleaching powder. Okay, so what do you have got? Calcium chloride, H2O, that is water, and chlorine gas. And the chlorine gas. Okay, and the chlorine gas. Again, Decon's process, what is it? Mark it important. It has come many times in the match the following. Okay, many times it has come in match the following, where they ask you Haber process, how did you prepare H2SO4, that is a contact process. Then what is Decon process, what do you prepare in Decon process, that is what they ask. Okay, now Decon process is very simple, very simple. If I react HCl, okay, I am heating HCl, I am doing combustion of HCl. Okay, combustion means what? Reaction with presence of oxygen. Simple as that, Prashant. So, isn't it obvious? What two elements I have over here? I have hydrogen and oxygen. That will give me water. And what is left? Only chlorine. So, it will give you water and the chlorine gas. It will give you water and the chlorine gas. Come on, write it down. The Decon's process. Okay, and this happens in the presence of a catalyst, that is copper chloride. Okay, that is copper chloride. I'm going to write it down. Decon's process. Important. Decon's process. Decon's process. Write it down and done in the chat box. Write it down and done in the chat box. Yes, everyone. Yeah, and also oxides. Okay, we have seen this reaction with the zinc oxides also. Oxides, what happens is chlorine, have more affinity, so they displaces the oxygen from the metal. Okay, chlorine displaces the oxygen from the metal. Okay, and again chlorine gas is released, you get the lead chloride and H2O is released. Okay, so remember, if you have lead oxide, no matter which lead oxide you have, it will give you chlorine gas. It will give you chlorine gas. Okay, it will give you chlorine gas. Now everyone, what is brine solution? Yeah, what is brine solution? Can anyone tell me? What is brine solution? Yeah, brine solution. Have you heard about it? Brine solution. No, Sarjana? Brine solution. Correct. It is the NaCl solution. Write it down. Brine solution is nothing but NaCl solution. Okay, brine solution is nothing but, write it down on top. Okay, because in the exam they will not give you NaCl. Okay, they will call it brine solution. You know NaCl, you know what reaction is going to happen of NaCl, but you are not aware that NaCl is called as brine solution, and you have lost your marks. That is very frustrating. Very frustrating. Okay, so it should not happen with you. You should mention on the top when such new words come. Please mention on the top. So brine solution is nothing but your aqueous NaCl or your sodium chloride, that is NaCl solution. NaCl solution. Okay. So if I do the electrolysis, simple electrolysis of NaCl. Okay, what happens at anode? Chlorine gas is released. At anode, the chlorine gas is released. Simple. And we take that chlorine gas, again one of the preparation of your chlorine gas. Simple as that. One of the preparation of chlorine gas. One of the preparation of chlorine. Is it clear till over here? Yeah? Is it clear? Okay. Then even the Downs process. Okay, Downs process, what do? We do the, yes, what happens in Down process, anyone knows? Okay, over here also we take, in the Down process, we take molten NaCl. Okay, we take molten NaCl. Okay, we take the molten NaCl. Now we have not done electrochemistry together, I guess, but still I'll tell you. Okay, molten NaCl means what? It is the liquid form of NaCl. It is not water. Are you getting it, Prashant? It is not water. We have just taken NaCl and we have melted it. That is molten. Now what is the use of that? What is the use of that? Okay, is if I do the electrolysis. Okay, while doing electrolysis, how many of you remember Faraday's law? Anyone? Faraday's law? Or how many of you remember electrolytic cell? Faraday's law is W is equal to ZIT. How many of you remember electrolytic cell? Yeah? Come on, raise hand option. Sarjana and Prashansky. Yeah? Come on, tell me, and Sarjana. Okay, first, and you go. What is electrolytic cell like? What happens in it? I do not want any detail. I just 2 sentences maybe. What happens to what? Or what happens in electrolytic cell?
Electrical energy is converted to chemical energy, sir.
What happens? Come again.
Electrical energy is converted to energy.
Okay, perfect. Perfect. Now one thing. Okay, correct. Sarjan also says electrical to chemical. Perfect. Now, what is the main difference? What is the main difference apart from electrical to chemical between your Daniell cell and your electrolytic cell? Do you know?
Spontaneous and non-spontaneous, sir.
Okay, one thing is there, spontaneous and non-spontaneous, correct. One requires external electric current, one does not. Okay, fine. Now, if I have, my point is, where I am coming from is, suppose I have electrolytic cell, okay. I have, what do we take? We cannot take solid NaCl, yes. So what do we take? We take the aqueous NaCl, yes or no? We take the aqueous NaCl. Now, when we take the aqueous NaCl, Sarjana, Prashanti, and okay, what is there one more thing which affects our electric current? Do we get Na and Cl at both anode and cathode? Is it so? Is it so? Do we get both Na and Cl at the cathode and anode? Is it so? At anode, yes, I'll tell you we get the Cl2 gas. Okay, we get Cl at anode. But at cathode, do we get Na? Do we get Na at cathode? Yes. And Sarjana, Prashansky. See, whenever you use electrical energy, the main difference is you are using electrical energy, you are giving the electric current. In the Daniell cell, you are not giving any electric current. The electrolyte that we use in the Daniell cell, that is Sarjana, Prashansky, and which electrolyte do we use in the Daniell cell? Yeah. Which electrolyte do we use? And Sarjana, Prashansky, which electrolyte do we use in the Daniell cell? Come on, tell me. Forgot? Which electrolytes do we use? We have 2 half cell with 2 different, same as the metal of the electrode. See, understand this. Daniell cell is different. Galvanic cell is different. Galvanic cell is the main heading. Daniell cell is a type of a galvanic cell. Okay, we have 2 types of cell, that is galvanic. Okay, we have 2 types of cell, that is galvanic and electrolytic. Okay, understand this. Galvanic and electrolytic. Okay, galvanic and electrolytic. Let us come back to our electrochemistry. Galvanic and electrolytic. Your galvan, in that you have Daniell cell as a type of galvanic cell. Are you getting it? Daniell cell is a type of a galvanic cell. Okay, and so in the galvanic cell we use what you answer, that is same as that of electrode. But in the Daniell cell, the electrodes and the electrolyte is fixed. That is zinc sulfate and copper sulfate. Zinc sulfate and copper sulfate, and that is also aqueous. That is also aqueous, correct? Now, in that the reaction happens wonderfully brilliant. We are not passing any electric current. But in the electrolytic cell, we are passing the electric current. And due to electric current, what happens? Yes, your Na plus and Cl minus, they separate out. But along with NaCl, who does ionize, who undergoes ionization by small amount? Yes, Prashansky and Sarjana, who get ionized just in small amount. The H2O, even your H plus and OH minus undergoes ionization due to electric current. And now there is a race between Na plus and H plus, and there is a race between Cl minus and OH minus. So for anode, yes, your Cl minus wins, but due to the over potential, due to the potential values, Your H plus means the cathode. You do not get any. You get the H2 gas. Remember this. You do not get any. H plus is there on the cathode. Is it clear? So that is a major drawback. Okay, that is a major drawback of your aqueous NaCl. We wanted Na, but we have got H plus. Now, what is the solution for this, Sarjana, Prashanti? And the solution is, do not use water. Use molten NaCl. Are you getting it? Use molten NaCl, and when we use molten NaCl, we call it as Downs process. Is it clear, Sarjana, Prashanti? Is it clear? And when we use the molten NaCl, we call it as Downs process. Okay, that is what I was referring to over here. That is what I was referring to over here. Where did we go? That is what I was referring to you over here. Where did we go? Over here. Downs process as a byproduct during the electrolysis of fused NaCl. Okay, that is your down. And in the electrolytic process, we take HCl solution. Okay, so we have H2 and we have Cl. Is it clear, Prashanti, Sarjana, and is it clear? Okay, chalo. So this was the preparation. So did you write down the brine solution? Write down this code. Come on, write down this code. Bleaching powder, Decon process, electrolytic process, and Downs process. Okay, for Downs process, you can simply write NaCl gives you Na and Cl2. Okay, that you can simply write Downs process. Downs process. Done, everyone. Prashanti done. Sajna done. Okay, chalo, let us go ahead. So chlorine, we all know it is a gas, correct? It is a greenish yellow gas. We can dissolve it in the water to make it chlorine water. Okay, 2.5 times heavier than water and a poisonous gas. Chlorine is a very poisonous gas. It has a suffocating smell. If you inhale it, you will undergo suffocation. Isn't it chemistry very weird? Yeah, chlorine is a very poisonous gas. Yeah, but if I combine with Na that we eat daily, we cannot survive without that. Yeah, we can survive, but we need it for the taste, isn't it? Like chlorine is very poisonous gas, but if I combine it with Na, what do I get? I get NaCl. Yeah, I get NaCl. So chemistry is a very funny thing, a very weird thing. Yeah, but look at the symbol, chlorine. It has made some very dangerous symbol. Yes, it is dangerous. It is a very poisonous gas. We cannot inhale it. Okay. Okay. So let us go with the further reaction of this are very simple reaction. I don't think even in the exam they might ask, but this reaction, third and fourth is possible. Okay. When you combine, your chlorine is very reactive. It reacts with the metals. It reacts with non-metals. Prashanti, it also reacts with metalloids. What are metalloids? Prashanti, Sarjana, and Ragul. What are metalloids? Gopinath. What are metalloids? Yeah. What are metalloids? What are metalloids? Yes, Prashanti, Sarjana, and what are metalloids? Yeah, how do we define? In between properties. Okay. Which are both metals and non-metals. Okay, we can say which show the properties of both metals and non-metals. Okay. Okay, both characters, some of metal, some of non-metals. Okay. So your chlorine is a very reactive gas. It reacts with your metals also, it reacts with your non-metals also, it reacts with your metalloids also. For example, if it reacts with metal, simply it will combine to give you chloride. Yeah, the most common oxidation state you have to see, and you have to find the, you have to form the chloride of that. For example, Prashansky, if I react sodium and chlorine, I will get sodium chloride. Calcium and chlorine, I'll get calcium chloride. Do not write it like this, CaCl. No, Ca is +2, correct? Cl is -1. That will be exchanged. Yeah, and what you will get? CaCl2. Yeah, do not forget. Otherwise, you'll write CaCl. Okay. Fe is more stable in +3, so FeCl3, AlCl3. That is your reaction with metal. Okay, metal and chlorine. Is it clear? Very easy. Okay, and same happens with the non-metals. So P4 10Cl2. If you remember this reaction, what happens? P4 plus 8Cl2 we had done. Yeah, it forms PCl3. It forms PCl3, correct? And if I react, if I do take excess of chlorine, then it forms PCl5. Yeah, then it forms PCl5. So if I react with non-metals also, like phosphorus, like sulfur, sulfur is generally in the acid form. Yeah, if I react with sulfur, phosphorus, it will form simultaneous chloride. It will form simultaneous chloride. Same thing, write it down afterwards. Even if it reacts with metalloids with the +3 oxidation state, yeah, astatine, sorry, not astatine, arsenic, antimony, yeah, arsenic chloride, antimony trichloride. Yeah, so that is, it reacts with metals, it reacts with non-metals, and it reacts with metalloids. Is it clear, Sarjana, Prasansky, and is it clear? Okay, is it clear? Okay. So look, I know it is a lot. I am going on, going on, going on. Let us take a 5 minutes break. Yeah, I can see your faces. Okay, let us take a 5 minute break. We'll continue at 8:35. Okay, take a 5 minute break. Go drink water. We'll continue from this. Okay, we'll continue from this reaction. Okay, but do not leave the session. Come back. Yes, everyone, back in the chat box. Let us continue. Chalo. Let us continue. Come on. Come on, back. Everyone, turn on your cameras. Chalo, let us continue. Come on, everyone is back. Give me yes or no. Prasanthi, Sajna, are we back? Okay, sure. Let us continue. Okay. Now, we have already discussed about the affinity of hydrogen towards halogen. It is too much. So, isn't it obvious if I react hydrogen with chlorine, what are we going to get? Yes, we are going to get HCl. We are going to get HCl. Yeah, we are going to get HCl. Similarly, if I react, if I dissolve chlorine in the water, yeah, if I get chlorine in the water, yeah, what I will get? Again, simple HCl. Yeah, simple HCl. Yeah, so same reactions. If you see, no, these reactions are very common. Okay, very common. Okay, I'll mark it important reactions where you have to actually focus. Now, KBr plus Cl2, very common reaction. You know what are you going to get? You are going to get chlorine will replace the bromine. Okay, why is chlorine replacing bromine? Like, will this reaction happen? KCl plus Br2. Do we get KBr? Yes, Prasanthi, Sajna. Will this reaction happen? KCl plus Br2. Will we get KBr and Cl2 gas will come out? Will it happen? Yes, Prasanthi, Sajna, and tell me, will it happen? This reaction I'm saying. KCl plus Br2. If yes, then why yes? If no, then why no? Yeah, what do you think? And Sajna, KCl plus Br2. Will this reaction happen and will we get KBr plus Cl2? Will it happen? Yeah, what do you think? Okay, and says no. Sajna, what do you think? Yes, Prasanthi, Sajna, will this reaction happen? If no, then why no? And why no? Why will not this reaction happen? Yeah, why will not this reaction happen? If you remember, okay, not only about electronegativity, what did I tell you? I have told you about the reactivity, correct? Fluorine is more reactive than chlorine, which is more reactive than bromine, which is more reactive than iodine. Okay. Now we know that in chemistry we go from less stable to more stable. Yeah, we go to less stable to more stable. Your chlorine is more reactive than bromine. That's why chlorine has more affinity towards potassium. Yeah, chlorine will have more affinity towards potassium because chlorine, yeah, it is more reactive. Your bromine cannot kick out chlorine. Okay, but vice versa, it is possible. Your bromine can be kicked out and you will form KCl. Similarly, chlorine can kick out I and you will find KCl and I2Br2. Is it clear, Prashanti, Sajna? Yeah, is it clear? Okay. Now this you have to write. What will happen in the cold condition and what will happen in the hot condition? Okay. So if I have a base that is sodium hydroxide and I react it with chlorine. Okay. A base sodium hydroxide. A base that is sodium hydroxide and I react it with chlorine. Okay. What I will get? I will get hypochlorite. This should be hypochlorite. Okay, not chloride, it is chloride. Okay, I get hypochlorite. Okay, chloride. Chloride means what? ClO minus is called as chloride. Okay, ClO minus is called as hypochlorite. Okay, remember, ClO minus is called as hypochlorite. So if I react the base with halogens in the cold condition, what will happen? They will give me sodium hypochlorite, NaCl, KCl, and water. Okay, but if I react it in hot conditions, I'll get the chlorine, that is ClO3 minus. That is a chlorine. Okay, that is a chlorine. Okay, now tell me, this is my ClO minus, that is my chloride. Tell me oxidation state of Cl in chloride and chlorate. Tell me, in chloride, what is the oxidation state of Cl? Prashanti, Sadhana, and Ragul. What is the oxidation state of Cl in ClO minus? Yeah, tell me. Cl in ClO minus, what will be the oxidation state? Correct? It will be plus 1. It will be plus 1. And ClO3 minus, what will be the oxidation state of Cl, Prashanti, in ClO3 minus? Calculate. Oxidation state of Cl in ClO3 minus. Yeah, correct, that is plus 5. Now we have to remember which is chloride and which is chlorate. See, how I have remembered, okay, I have found out one trick, that is chloride, okay, ClO minus, oxidation state plus 1. Okay, so in the chloride, what we have I. I is like a Roman number 1. Yes, I is like a Roman number 1. So we can consider I as Roman number 1. We have one oxygen, we have oxidation state plus 1. Okay, so chloride is where you have one oxygen. Chlorate is something where you have 3 oxygen. Is it clear? Chlorate is something you have 3 oxygen. Chloride is something that you have 1 oxygen. How I will remember? From the 1 or the I that is present in the chloride. Okay, so in the hot conditions, you get a chlorate. So in the hot condition you get the chlorate. In the cold condition you get the chloride. Come on, write down this reaction. First write down for cold. Write down any one of it. Write down the first reaction. Come on, write it down, Prashanti. Write down any one reaction. Write down for the cold NaCl, cold, that is NaOH plus Cl2. Okay, base plus chlorine in a cold condition. Okay, so this is a temperature dependent reaction. These are your temperature dependent reaction. At low temperature it behaves differently. At high temperature it behaves differently. This reaction and tell me done. Sodium hypochlorite. And similarly, write down just below that first reaction the second reaction with respect to hot. Get the chlorate. So get the chlorate. So whenever you have hot conditions, you get the chlorate. Hot conditions, chlorate. Simple as that. Okay, simple as that. Hot condition, you get the chlorate. Done? Yes. Write down the milk of lime on the top of it. Okay, just like brine solution, Prashanti. Write down milk of lime. What do we call it as a milk of lime? Is a calcium hydroxide. Write down on the top so that if it comes in the exam, you have to remember milk of lime is nothing but your calcium hydroxide. Yes, write it down on the top. Milk of lime is nothing but your calcium hydroxide. Yes, milk of lime is nothing but your calcium hydroxide. Okay. Milk of lime is nothing but calcium hydroxide. Milk of lime is calcium hydroxide. Write down this reaction. On the third reaction also write it down. Milk of lime. Write it down. Write down the third reaction and tell me done in the chat box. Come on, everyone. Write down the reaction and tell me done. Done. Okay, sure. Let us go ahead. Yes. Then reaction with ammonia. Okay, now again this reaction we have done in the group 15. Yeah. Reaction with ammonia depends upon what I have in excess. Depends upon what I have in excess. If ammonia is in excess, I will get ammonium dominated compound, that is ammonium chloride. If sargana chlorine is in excess, then I will get chlorine dominated compound, that is nitrogen trichloride. Yeah. So depending upon what I have in excess, Prashanti, if I have excess of ammonia, come on, write down this reaction again. It is there in the group 15 also. If I react with ammonia and chlorine, simple reaction. Ammonia and chlorine combine to give you ammonium chloride. If ammonium is in excess, that is ammonia is in excess, and ammonium and your chlorine combine to give you nitrogen trichloride, which is explosive. This you will get if your chlorine is in excess. If your chlorine is in excess. So ammonia excess, ammonium dominated compound, ammonium chloride. If chlorine is in excess, chlorine dominated compound, that is nitrogen trichloride. That is nitrogen trichloride. Come on, write down the reaction. Yeah, ammonium dominated compound and the fluorine dominated compound. So if ammonium dominated compound, that means ammonia is in excess. Chlorine dominated compound, your chlorine is in excess, that is nitrogen trichloride. Okay. Now next we have is when you react carbonyl and chlorine. Okay. Carbonyl, that is not carbonyl, we can say carbon monoxide. Okay. Carbon monoxide and chlorine, we get a compound called as phosgene. Okay. I find the name very funny. Phosgene. Okay, so it looks like this: C double bond O, Cl, Cl. Okay, this is nothing but a phosgene. This is nothing but a phosgene. Okay, that is a carbonyl chloride. Carbonyl chloride. So write down this reaction also important to get the phosgene. That whenever you react carbon monoxide with the chlorine gas, yes, the chlorine gas is attacking carbonyl compound to give you carbonyl chloride. That is phosgene. Okay, that is phosgene. So this what we are doing the chemical properties of chlorine. We are doing the reactions of chlorine. Yeah, different reactions, different possible reactions. Now again I'll repeat, I have taken everything from your textbook, everything possible from your reference book. Okay, what happened, Sarjana? I got scared.
Sir, here there's a power cut, sir.
Power cut. I got scared suddenly. I could only see, oh, your smiling teeth. That's it. Oh. There is a power cut and Sarjana is smiling. Imagine. I could see only everything black. Okay. Only thing that is visible are her teeth and the earphone, the red bright earphones. Fine. I got scared suddenly. What happened? Okay, is it that that scare technique is there? Yeah, suddenly something comes on the picture. Huh? No, I'm not saying that you are scary. Okay, just because the lights went out. Okay. Okay. So come back. So carbon monoxide, if it reacts with chlorine, you get the phosgene. Okay, which is again toxic, which is again pungent smelling gas. Okay, that is a phosgene. Okay, same thing happens with nitro compound, same thing happens with SO2. Okay, nitro compound, you'll get the nitrosyl chloride. With the sulfur dioxide, you'll get the sulfuryl chloride. So it looks like this: S double bond O, you do not have OCl bond, remember, Cl. Just like phosgene, this is your sulfuryl chloride. Okay, this is your sulfuryl chloride. Okay. Similarly, NO, if I react with NO, I'll get the nitrosyl chloride. Okay, I'll get the nitrosyl chloride. So NO and SO2, nitrosyl chloride and sulfuryl chloride. Nitrosyl chloride and the sulfuryl chloride. Okay, nitrosyl chloride and the sulfuryl chloride. Okay, then it is used as an oxidizing agent. Chlorine is an oxidizing agent. Chlorine is an oxidizing agent. For example, look at this, Sajna, and look at this. So I have a chlorine, I am reacting it with sulfur dioxide. Okay, chlorine is reacted with sulfur dioxide. So it is converting sulfur dioxide to H2SO4. Now Sajna, Prashanti, and come on, tell me, what is the oxidation state of sulfur in sulfur dioxide? Yes, what is the oxidation state of sulfur in sulfur dioxide? It is fine, Sajna. Okay, the lights are out at your place, it is fine. Even if you do not answer, you can answer if you can do it orally. Do not take your book like this. Okay, that is fine. So, what is the oxidation state of sulfur in sulfur dioxide? Correct, and Prashanti, what is it? It is nothing but plus 4. It is plus 4. And what is for sulfur in H2SO4? Sorry. Yes, sulfur in H2SO4, it is plus 6. So, plus 4 to plus 6. Is it oxidation or reduction? Sajna and Prashanti. Gopinath, is it oxidation or reduction? Ragul, yes. Plus 4 to plus 6. That means what? Prashanti, donation of electrons. That means it is oxidation. So yes, this proves that yes, your chlorine is acting as an oxidizing agent because it is oxidizing sulfur. Now look at the chlorine. Chlorine is getting converted to Cl2 to HCl. Now in the HCl, what is the oxidation state of Cl? Yes, everyone, in the HCl, what is the oxidation state of Cl? Yes, Arjuna, what is the oxidation state of Cl in HCl? It is nothing but -1. Oxidation state means charge. Okay, so do not get confused. H plus Cl minus. So -1. Over here, whenever it is in elemental state, we consider it as a 0. So 0 to -1, is it oxidation or reduction? Yes, 0 to -1. Sarjana, is it oxidation or reduction? It is reduction. It is reduction. So this proves that yes, Cl2 is undergoing reduction. Your SO2, your sulfur is undergoing oxidation. That means my chlorine is acting as an oxidizing agent. It is oxidizing the sulfur of SO2 and it itself is undergoing reduction. Is it clear, Sadhana? And is it clear? Finally, yes. Whenever the lights used to come at our place, and if we had a candle for the light, we used to sing happy birthday, the whole family. I never knew why this existed. We used to sing happy birthday just to blow out that candle. Yeah, okay. Now over here also, if you see, chlorine will convert sulfide to sulfate. That is also over here also, it is acting as an oxidizing agent. Okay. Everywhere, if you check every reaction, nitrites to nitrates, okay, ferrous salt to ferric salt, okay, all these reactions, you can write it down afterwards. All this reaction proves that chlorine is an oxidizing agent. Chlorine is an oxidizing agent. It oxidizes the other molecule, but itself undergoes reduction. Okay, is it clear till over here, everyone? Yeah, same over here. Iodine to iodic acid. What is the oxidation state of iodine in iodic acid? Yes, everyone. Calculate. Sajna and Prashanti, Gopinath. Calculate. Iodic acid. What is the oxidation state of iodic acid? Yes. Oxidation state of iodine in iodic acid. What is it? Correct, Sajna, correct. And it is nothing but plus 5. Yes, and iodine is 0. So again, iodine 0 to plus 5. Is it oxidation or reduction? Yeah. Is it oxidation or reduction? 0 to plus 5. It is oxidation. Yes, who is responsible? Yes, Cl2 is responsible. So again, chlorine gas is acting as an oxidizing agent. It is converting iodine to iodic acid. Clear, Sajna, and is it clear? Okay. Now, as I told you, your interhalogen compounds. Yeah, interhalogen compounds. Isn't your like it is like your siblings? Yeah, you fight with your siblings, yes or no? Yeah, Sajna. And do you have younger, elder? What type of sibling do you have? Younger or elder? Prashansky? Yes, younger sibling, elder sibling, and has a younger sibling. That means he or she is gone. Yeah, always the elder siblings are more powerful, isn't it? Or younger. Youngers are the favorite one of parents. We can agree on that, isn't it? Like even I have an elder brother. Okay, so I am the favorite of my parents. So younger are like more favorite of the parents. Imagine if I was not favorite of my parents, like will they allow any boy or a guy to grow hair till the waist length? Yeah, like a girl? No, obviously not. Yeah, so youngers are more favorite of parents, isn't it? But we still fight, isn't it? We still fight younger and elder siblings. So your interhalogen compounds are like that only. Okay, they are fighting. Yeah, and only thing is always and always elder brother throws younger brother here and there. Yeah, same case over here. Smaller atoms will be more in number. Okay, your elder brother is throwing you everywhere. It is like that only. Younger is in the greater quantity. That means the smaller atoms of your halogens will be of poly compound. For example, if I react chlorine and fluorine, if it is an equivalent amount, I will get ClF, no issue. But if fluorine, if I take more, what I will get? ClF3. I will never have a compound like FCl3. Not possible. Because isn't it a common sense? Like a smaller compound cannot hold so many larger compounds. Simple logic. Okay. So whatever you have in the poly, that has to be the smaller atom. That has to be smaller atom. Same over here, bromine and chlorine, bromine chloride, yeah, bromine monochloride, iodine chlorine equivalent form, it should be iodine chloride. Okay. Yeah. Okay. Now these are organic reactions. Don't worry, we'll do it in the organic chapters where your chlorine is being substituted. Since there is a chlorine reaction, that's why I had put it over here. All these are organic reactions. Yeah, organic reaction where your chlorine, yes, where your chlorine is being substituted, your substitution reactions. Okay. Now chlorine is used as a bleaching agent. Yes. If you remember the other bleaching agent that we did, the temporary one, which one was it? Temporary bleaching agent. Yeah, which one was it? And Sarjana, do you remember? Yeah, which one was it? The temporary bleaching agent. I told you about hair thing, yeah? Yes, who has the temporary effect of bleaching agent? Yes? Yeah, everyone? Sajna? Which one was your temporary bleaching agent? Was it CaOCl2? No. CaOCl2 is a bleaching powder. Yeah? It is not a bleaching agent. Temporary bleaching agent. Bleaching means what? And Sajna, we discussed this. Yeah, N was not there in the last class. And did you ever colored your hair? Ever? Did you ever try to become a TikTok star where you color your hair red, purple? Last time we imagined Sajna with all the red hair. Yeah, isn't it? Okay, so what do? They bleach our hair. Now imagine yourself growing out the red hair. If you want to color your hair red, okay, you want to color your hair red. Now what you have to do, not you, the professional salon person, what he'll do, he'll apply the red color. But when he applies, you already have the black color hair. If I apply the red on my black color, it will not become red. It will become the combination of black plus red. So what they do, first they put a cream which is a bleaching cream, okay, which strip out your complete black natural color. Okay, it makes your hair complete white. Then they apply the red color so that it will be perfect red. So, and I'm telling it to you also, do not color your hair ever. It is not good for your hair. Okay, so that is a temporary action, but over here permanent action. of bleaching agent. Now, in the temporary action, we discussed about the sulfur dioxide. Okay, so at the top, and SO2 is a temporary bleaching agent. SO2 is a temporary bleaching agent. Okay, that means what? Again, it becomes color, like if it is colorful, it reacts with the pigment. Yes, it reacts with the pigment. Okay, your sulfur dioxide, it becomes colorless. Okay, it becomes colorless, and again it reacts with the any oxygen. Okay, just like air, we have oxidation, it again gets the color. But that is not case with the chlorine. Chlorine is a permanent bleaching agent. It stops whenever you have a pigment, it will react and it will become colorless. Again, it will not undergo oxidation. Is it clear, Prashanti? Is it clear? And yeah. Okay, so these are the uses. Chlorine uses. We have the bleaching. We have already discussed. Bleaching means something to give color or remove color, basically. Okay, so manufacture of dyes, drug, organic solvent, vinyl chloride, DDT. You must have learned about it in the organic chemistry. What is DDT? Full form, Prashanti, and I will not say full form, but what is DDT? Yeah, what is DDT? What is DDT? Correct. It is an insecticide. It is an insecticide. Yeah. So in the insecticide also you have a chlorine. That is your dichloro, if I am not wrong, dichloro, diphenyl, trichloroethane. Correct. Dichloro, diphenyl, trichloroethane. Yes. So it is like this. You have a ethane molecule, carbon, which already has trichloroethane. Then you have diphenyl. So let us say this is my aromatic ring. It does not look like one. This is my aromatic ring. Okay. And at the para, I have a chlorine. At the para, I have a chlorine. Okay. So this is dichloro, diphenyl, Cl, trichloro, and your ethane. And your ethane. Yeah. And your ethane. This is carbon, two carbon for ethane. So diphenyl, dichloro, and trichloroethane. Yeah, that is your DDT and insecticide. Okay, so it is there in the DDT form.